Hello and welcome to another Orange Coast College mathematics video. In this video, we're going to learn to add and subtract radical expressions. To do this, I will assume you're familiar with simplifying radical expressions. Now, to add and subtract radical expressions, we simply need to combine like terms. I can combine any two like terms, for radical expressions are any two terms that have identical radical expressions. So whatever's underneath the radical, whatever's in there, the radicand, that needs to be the same. We start with this example. The first step we must do here is simplify each radical expression. So 32 can be written as a perfect square, 16 times 2. 18 is also a perfect square, it's 9 times 2, or can be written as a 2 times a perfect square. And then for the final one here, 3, the square root of 12 is 4 times 3. Okay, so I factored each number so that you can see the perfect square in its factors. And then you simplify by pulling out that perfect square. So the first one becomes 4 root 2, because again, 16 is the square root of 4. Second term will be 3 root 2. And for the last one, I'll have 3 times 2 root 3. Okay. Now, the first two terms have identical radical expressions, right? It's the square root of 2. So this is just 4 square root of 2 minus 3 square root of 2. That will simplify. If you want to, you can just factor the square root of 2 out of them. So you'll have 4 minus 3 square root of 2 like that. And then over here, we have 6 times the square root of 3. So that if we simplify this, this will just give us 1 square root of 2, or just square root of 2, plus 6 square root of 3. Now these radical expressions here are different, right? The radicands are different. It's 2 and 3. They can't be simplified anymore, so we're done. Example 2. Again, we start by simplifying each expression, because as they currently are, the radicands here are different, and we can't simplify them. We can't add them until they have identical radicands, if they can have identical radicands. Okay. So for the first term, 50, I can write that as 25 times 2. Again, I want to find the perfect squares. When I want to factor those numbers to get the perfect squares in there. So it's 25 times 2x. And 8x, I can write that as 4 times 2x. And then we simplify this. The 25, we can pull the 25 out as a 5. Again, 5 is the square root of 25. So it's 5 times the square root of 2x. Plus for the second term, we can pull the 4 out as a 2. So 2 times 2x. And we have 5 root 2x plus 2 root 2x. So that adds up to 7 root 2x. That's it. Example 3. Now this problem is a little bit more complicated, but only because of the simplification we have to do to these radical expressions. So we look at each term, they're both cube roots. So we need to simplify each term. Now, since we have cube roots, we want to write factors in here that are perfect cubes. So 54 can be written as 27 times 2, and 27 is a perfect cube. It's 3 cubed. And then z to the 7th, if I write that as z to the 6th, that's a perfect cube. So I can write as z to the 6th times z, okay? Because z to the 6th is also a perfect cube. It's z squared cubed. The second term, we have this z out here, and then we have the cube root. So negative 16 is negative 8 times 2, and negative 8 is a perfect cube, is negative 2 cubed. And z to the 4th, I can write that as z cubed times z. Okay. Now the next step is to just simplify those, pull out the perfect cube. So 27, as I mentioned, that was 3 cubed. Z to the 6th, that is the cube of z squared. And so we're left with 3z squared times, what do we have left in there? We have a 2z. Okay. For the second term, we have z times, we have negative 2. And then we'll have z times the cube root of z cubed, which is z. So we'll also have a z squared out here. And we'll have left under the radicand 2z. And again, you can only combine these like terms, combine these terms if they have identical variable and radical expressions. So notice here, the variable part outside the radical match, they're both z squared, and the part inside matches. And we need both of those things. And of course the roots are the same. They're both cube roots. Okay, so we can combine these like terms. And so what we end up with here is 3 minus 2 times z squared cube root of 2z. So that just leaves us with 1 z squared times the cube root of 2z. Here's our final example. Again, we need to start by simplifying each term. So for the first term, we have x 27. I can write that as 9 times 3. Again, we're back to square roots here, so we want to sort of find the factors within that are perfect squares. And then we have x cubed can become x squared, and then we'll have times x, and then we'll have times y there. For the second term, 12 can be written as 4 times 3. X to the 5th can be written as x to the 4th times x. Again, x to the 4th is a perfect square. And we have that factor of y in there as well. And then for the final term, we have x squared times the square root. So 75 can be written as 25 times 3, and then x times y. Okay. The next step is to, again, pull out the perfect squares from underneath the square roots, take them outside as their square roots. So here we have 9 and we have x squared. So those will come out as 3x. So we have x times 3x gives us 3x squared times the square root of, we'll have left under the radical 3xy. For the second term, we have perfect squares 4 and x to the 4th. So the square root of 4x to the 4th will be 2x squared. And then left under the radical, we will have 3xy. And for the final one, the only perfect square we have in here is 25. So we can pull that out. It'll be 5x squared times the square root of 3xy. And again, we have the same variable term for each term, same variable, and we have the same radical expression in each term. And that means that we can combine these, and we'll get, so it's simply going to be 3 minus 2 plus 5, so that's just 6x squared times the square root of 3xy. That's it for adding and subtracting radical expressions. This can be challenging, so practice it. You'll have it down in no time. Until next time, have fun.